All right, so this is the very first lesson about logarithms, and I call them the mostly commonly referred to as logs. In the notes, I teach you, or I tell you, logs are pretty much just finding bases with powers. So I tell you this. In the example, I say log 16 of base little 4 equals 2. Now, the way you always read these is this. You say log this number, and then this number is called your base. Log 16 of base 4 equals 2. But what I tell you in the notes is, think of it like this. Base, exponent, what it equals. Base, exponent, what it equals. This is called logarithmic form, and the inverse to a logarithmic form is exponential form. Log form, exponential. The way you get rid of a log, there's only one way to get rid of a log, and the way you do it is you change it to exponential form. So in the notes I say base, exponent, what it equals. 4 squared equals 16. Logs are just another way, technically, to write exponents. They do a lot more things than just figuring out exponents. But starting off, just basic stuff. Let's look at some examples, not on the notes, but let's say this. Let's say we have log 25 of base 5. What is this equal to? Well, the way you always want to do it is you always want to rewrite this. You would say, this is my base. I don't know what it's equal to, so I'm going to give it a variable. 5 raised to some power equals 25, which is x equals 2. This would be a 2. How about if I say, let's say, let me think about this. Do you think you can figure that out? Log the cube root of 8 of base 8. Well, if you don't know what this is right off the bat, always change it to exponential form. Base, exponent, which you don't know, and what it equals, the cube root of 8. How do you get 8 inside a cube root? Well, this x would have to equal 1/3 because 8 to the 1/3 power is the cube root of 8. Logs are that simple. Look kind of weird, but it's truly that simple. Let's say log of, let's say we don't know it. We don't know the base. Let's say 1 over 16 equals -2. What's the base if log of 1/16 of base x equals 2? Well, rewrite this in exponential form. Base, exponent, what it equals. So what number raised to the -2 equals 1 over 16? It would have to be 4, because 4 to the -2, remember you flip it, becomes 1 over 4 to the +2, which becomes 1 over 16. Okay, let's diverge a little further now. Now I'm going to talk to you guys about common logs. Common logs are, sounds like super lame to say, but common logs are really common in Math 3. Common logs have to do with invisible base. This is always going to be a 10 in common logs. So if you do this on your calculator, just pause this and go log 100 on your calculator. Log 100, if you pause it right now and do log 100, what does it equal? Do it. All right, it's going to give you 2 as an answer. Calculators only compute logs with base 10. They only compute common logs. The reason why it equals 2 is whenever there's no number, you can assume it's a 10. The reason why it equals 2 is this invisible 10 squared is what gives you 100. So let's look at some example problems. Can you figure this out? What's log of root 10 equal to? Well, if you don't know what it's equal to, rewrite it in exponential form. Remember, there's an invisible base. Base exponent, which you don't know, equals root 10. What does this have to be raised to equal square root? 1/2. How about log 10 to the 5th? What does that equal? These look kind of weird, but if you rewrite this, look, your invisible base is 10 and you don't know what it's equal to. So you have to solve base exponent what the whole thing equals. 10 to the 5th. 10 raised to the what equals 10 to the 5th. It's that simple. Yes, 5. That's why log 10 to the 5th, a base 10 equals 5, because 10 to the 5th equals 10 to the 5th. It's kind of like a weird puzzle. Once you understand the little pieces, everything else gets put into place. Let's try another one. Log 1/125 of base 5. Let me ask you a question. Is this right here a common log? The answer is no, because there's a base here. It's 5. It's not an invisible base 10. So what this is asking is 5 raised to what power equals 1/125? The answer is -3. So this is equal to -3 because 5 to the -3rd becomes 1/5 to the +3rd, which is 125. Okay. I think you guys can fill in the pieces now with common logs. What I'm going to talk to you guys about now is, it looks a little more in depth, but it really isn't that much. It really isn't too much more in depth, and it is called natural logs. On your calculator, natural logs look like this, ln. And natural logs have an invisible base of e. Now, I'm going to get my calculator. I'm going to show you where it is on my calculator. My e is right here. So if I want to figure out what e equals, I'm going to turn it on first. That's important. I'm going to raise e to the first power, and e equals 2.7 and change. So technically, e has a value. It's like, think of it as like, you know how pi is equal to 3.14, blah, 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 whatever. It's just a symbol that represents a numerical number. E is the same way. E just represents a number. Some people might ask, what the heck is E used for? All kinds of things in higher level mathematics. But for right now, for this course, all you need to know is E is used in natural logs. So if I give you an example, natural log E equals 1. Why? Well, I explained to you that whenever it's an ln, it's called a natural log. It's an invisible base e. E raised to this exponent equals this. Base exponent, what it equals. Base exponent, what it equals. Even though it's a natural log, it still works the same as normal logs. And now I give you a couple problems. Natural log of e to the 5th. What does this equal? So a lot of people will look at this and go, oh my gosh, I don't know. This looks kind of weird. Well, natural log of e to the 5th. Rewrite it in exponential form. The missing base is an e because it's a natural log. E raised to some exponent equals e to the 5th. Base exponent, what it equals. And it's that simple. E to the 5th, this is 5, equals e to the 5th. Easy. Let's try this. Natural log of e to the -3rd. What does this equal? The answer is actually -3. If you can look at that and go, oh wait, if I rewrite this, my invisible base is e. The exponent, I don't know. Base exponent, what it equals. What does this have to be to look like this? It's as simple as this. E to the x equals e to the negative third. This has to be it. Negative 3. And then the very last one. What is natural log of 1? If you plug natural log of 1 into your calculator, watch this. It's going to spit you out a pretty interesting answer. Natural log of 1 equals 0. Why? Why in the heck does natural log of 1 equal 0? Well, if you convert it to the inverse, meaning you break it down, or not inverse, but exponential form, if you break it down in exponential form, this is your base, e, and let's say you didn't know this was 0, e raised to some exponent equals 1. Base exponent, what it equals. Anything raised to the 0th power equals 1. That's always how it equals 1, because each of the 0th power equals 1. Do you guys remember a couple classes ago I asked you why anything to the 0? Oh no, that was IM2. Do you know why anything to the 0th power actually will always equal 1? It's a really simple answer. Let's say 50 raised to the 0th power equals 1. Negative 3 raised to the 0th power equals 1. 89 raised to the 0th power equals 1. Why? Anytime you raise something to the 0th power, it equals 1. The reason why is this. If I rewrite 50, I can put a 1 times 50 raised to the 0th power, right? 50 raised to no power means it's gone. And nothing times 1 is 1. It's gone. There's an invisible 1 here. Negative 3 to the 0th power means it doesn't exist. The 1 is left. Because technically, you can mathematically manipulate numbers. I can throw a 1 in front of this, and it's the same thing as if there wasn't a 1. 89 to the 0th power means there is no answer. It's not 0. This doesn't equal 0. It's just it's not there. And then 1 times just nothing that's not there is just 1. That's why. So for your worksheet today, you have a good amount of questions, but you see how these questions don't require really any work, and it's very simple. That's why there's a lot of questions, because they will take you the same amount of time as a normal assignment, but there is many, many more questions. Because look, how long does this take you, for example? Let's say log 3 of base 9. What does this equal? Well, rewrite in exponential form. Watch how long this takes. 9 raised to some power equals 3. The square root of 9 is 3, so this would have to be 1/2, because 9 to the 1/2 power is 3. See, there's no work to really show. I just want you to show the exponential form. Whenever you get a log question, rewrite it as an exponential form. That's all the work that you need to show.